Now let's see about log-based protocols. The log-based protocols are mainly based on locking a data item before you access it, and this lock has to be done appropriately. For example, if you have a data item, let us say A, and now you want to read it, then you have to lock it and then read it. And if you want to write it, then you have to lock it and then write it. But then reading and writing are actually two different kind of operations. While you are reading the data, you can allow some other transaction also to read the data. But while you are writing the data, till you finish that operation, it is better you don't allow any other transaction to write on it. Otherwise there will be inconsistencies like that race condition in operating system, right? So mutual exclusion and all. So it is exactly the same as mutual exclusion which we have done there in operating systems. But here, since we have read and write both of them, so we are going to use two different locks. So now we can assume that we have two different types of locking. One is called as shared lock. Shared lock. So shared lock means if you are going to read a data item, then you are going to apply a shared lock on that, right? And this is also called as read lock, which means it is mainly used for read lock. And now if you want to lock a item using read lock, the command generally we use is lock_r, which means read lock on A, right? And the other one is exclusive lock. Exclusive lock means if you want to write a data item, then you take an exclusive lock on it and no one will be able to read or no one will be able to write that. Okay, now it is also called as write lock. It can be written like this, lock_w A. So the conventions which they use to write the logs, they vary from textbook to textbook, and in the exam they will clearly tell you what does it mean. I mean, they will say that lock_r of A is locking A, the data item A, for reading, right? And locking data item A for writing, exclusive and shared. Now what is the relationship between shared and exclusive is, if you have shared lock and exclusive lock, let us say I am writing it like this. Now if you already have a shared lock on a data item, then you can have one more shared lock on the same data item, which means if a data item is already logged under shared mode, then someone else can request for shared lock and they can get it. Now if you have logged a data item in shared mode, then someone else cannot lock it under exclusive mode. So these two are not compatible. Got it? So let me write yes and no. So X means exclusive locking, X means exclusive locking, S means shared locking, right? So these two are compatible, which means if you are already having a shared lock, yes, you can ask for one more shared lock on that. If you already have a shared lock, you cannot ask for exclusive lock. These are the general rules, right? Which means any number of transactions can read the same data, but then while someone is reading, no one should update it. That is the meaning of it. And while someone is updating it, no one should read it. That is why if a data item is already logged under exclusive mode, then again locking it under shared mode is not allowed, right? And it is also not allowed. Got it? So from this table you should be able to understand that any number of transactions can read at the same time, but then even if one of them is going to write, then no other transaction should access it. This is what is simple locking. In simple locking we don't have anything else, right? Now what are the problems with simple locking? Why do we need more features in simple locking is, I'll take an example and explain you. Let us assume that we have two transactions, T1 and T2, and one transaction is trying to transfer an amount of, let's say 50 rupees from account A to account B, and other transaction is trying to display a sum A plus B. What is the total amount present in A plus B? Now this is what both the transactions are trying to do. Now for that reason, let us say there is a schedule possible in locking. Now the schedule is like this. It is not a serial schedule. The schedule is like this, T1 and T2. Now T1 will take a lock on A, and then T1 will first take a lock on A. Let us say lock exclusive of A, which means T1 is going to take a lock on A, and it is going to write A before writing it, it will try to read it, right? So lock shade of A, it is going to read the value of A, right? After locking, it is going to read the value of A, and then unlock A. Let us say unlock shade of A. Got it? Which means we logged A and read the value of A, and then we unlocked A. And now again lock A for exclusive, and you try to decrement the value of A equal to A minus 50, and then release A. So unlock A. Got it? So now I unlocked A. So what did I do? I read the value of A and I decremented the value of A, and maybe I have written the value of A, right? Let me write it. Write the value of A and then unlock it. Okay, so till this part I didn't do anything, I just decremented the value of A by 50, right? And now let us assume that by locking and unlocking, T2 has at this point started this operation A plus B. Now since it has released all the locks it has been holding on A, T2 will be able to get a lock on A, which is nothing but shared lock, and get a lock on B, which is nothing but shared lock, and now it will try to display A plus B, right? Now what happens is, we are in the middle of the transaction. Now assume that initial amount that A has is 100 and initial amount that B had is 200. Now after transferring, A will have 50 rupees remaining and B will have 250 rupees remaining. Got it? Now the sum initially, if you compute it, is going to be 300, and the sum if you compute it later is going to be 300, right? So at any point in time, if you compute the sum, it has to show us 300. But now at this point, if it tries to compute the sum, this is going to show us, since A has been decremented by 50 and this amount has not yet been added to B, and at this point you are trying to compute the A plus B, you are going to get a number of, I think 50 plus 200 is 250, right? So which means this is inconsistent, right? So you are going to see inconsistent data. Therefore by just acquiring the locks and then releasing them immediately in the simple protocol, we are not able to produce consistent results. Inconsistent results are still possible. Now why do you think that this problem has occurred? Because you are in the middle of the work and you have released the locks too early. If you would have held the locks for some more time, then this transaction would have waited, isn't it? Now you have released the lock on A, therefore they are reading the temporary value of A, which is not actually right, isn't it? Or even though the value of A is permanent, you should have waited for B, right? Therefore releasing the lock too early in the simple locking case is going to give us the inconsistent results. That is one problem, right? And the second problem you might see is, there may be a deadlock. So let us assume that, say there is simple locking, and let's not think about this transaction. There are some other transactions T1 and T2, and some schedule may be possible like this. Let us say there is a transaction which is running, and this transaction has acquired a lock exclusive A. It has taken a lock on A, right? And now assume that on the other side someone has logged B, right? Now assume that on the other side, now B wants, the next lock is transaction T1 wants exclusive lock on B, and transaction T2 wants exclusive lock on A. Let's say there is some situation which has got like this. Now what is the meaning of it is, the data item A has been locked by transaction T1, right? And then there is transaction T2, and data item B has been locked by transaction T2, right? And now transaction T2 wants a lock on T1, and transaction T1 wants a lock on B. right? Now if you observe this, there is clearly a cycle because of which there is going to be a deadlock. Therefore, if you just allow the simple locking to be done, then there is a chance that there might be a deadlock. Even if it is not the exact way, there might be some other way we might get into deadlocks. Exactly the same way we have seen in operating systems, right? This is also a problem. And also one more problem might be, see, you are getting the problems. So if you just allow simple locking to be done, then one problem is inconsistent results, second problem is deadlock, and the third problem is they might not always guarantee any serializable schedules. So what I mean by this is, let us assume that we have two transactions like this. Now transaction T1 has got a lock, let's say exclusive lock on A, and it is writing on A, and then it has unlocked A, right? And then let's say transaction T2 has now asked for shared lock on A, and then it read the value of A, and then it unlocked the value of A, unlocked the data item A. And again here transaction T1 has obtained shared lock on A, and let us say it has again written the value of A and again unlock A. So there might be some other actions in between, but what we wanted to see is what happens in this scenario. The main transactions which I want to see is this. And now if you observe it, there is a write-read dependency here and again read-write dependency here, right? Now this one is saying that this T1 then T2, this one is saying that T2 then T1, right? So what is it? There is a cycle possible here, and so this is not going to be conflict serializable, right? So which means by going with the simple locking, just locking and unlocking immediately, right, I might fall into various problems. So there is even no guarantee that I'll always be able to get serializable schedules. So something more has to be added to the simple locking protocols. Just providing the exclusive access to data items is not going to solve our problems. Yes, it is going to solve our problems in some cases, but then in some cases we might get into trouble. So what are the three problems we might face? One is inconsistent data, other is deadlocks, and the other one is serializability may not be guaranteed. That is why we are going to add more things to simple locking. We shall see it in the phase locking. Okay, so we are going to have two-phase locking next. Fine.